Welcome to the Living Periodic Table. Today we're going to talk about uranium. First, we'll talk about the different samples that I have for uranium in the Living Periodic Table. The first two are ore, and I got those from eBay. And so the first one has that classic green color that everyone envisions when they think of uranium. That's why I got it. Was just because it looked cool. And then here is what a lot of uranium ore looks like. And it's just this dull, normal looking rock, but that is embedded with uranium inside of it and is radioactive, as we'll investigate here in a second. And then I have uranium powder. The seller says it is from a spent fuel rod. And there's the powder down at the bottom of the vial. And this is a sealed vial. And then we have uranium metal that I bought from a chemical supply company. And it came in a sealed glass ampule. Okay, so now we're going to take my Geiger counter here, and I have it set for CPM. So every click that you hear is a piece of radiation hitting the sensor inside of the Geiger counter. And we're just going to look at each sample and look at how much radiation each sample puts off based on how many clicks that you hear. This is just background radiation right now. There's radiation all around us all the time, and that's just hitting the sensors right now. Uranium is an alpha and beta emitter, and you can see it immediately increases. So this is highly radioactive. A lot of people ask me, why do you have uranium inside your house? How are you safe? How is your family safe with this type of radiation around you? And what I always tell them is, since this is an alpha and beta emitter, the ability for this radiation to penetrate and to travel long distances is extremely poor. Because you can see, you just back it off a little bit and immediately the radiation decreases. I'm having to put this right up against the sample to get these high levels of radiation. And so we're putting off some pretty good radiation from that sample. So now we're going to trade out the sample, and we'll go for another piece of uranium ore, and we'll see how radioactive this sample is. You can see the numbers dropping. There's far less uranium inside this sample of ore right here. Numbers are continuing to drop. So those less radioactive. Now the problem with alpha particles is they have a tough time penetrating your dead skin, let alone a glass vial. So we're already at a detriment because this is inside of a glass vial here. So basically, the only radiation we're going to pick up is the beta particles that are able to go through that glass. And so you can see this is not very, very radioactive. But if I were to take that sample out of the glass container, we would start picking up those alpha particles. And again, we would get a very high level of radiation off of that sample. So next is the uranium metal. Again, it's in a glass container, so we're shielded from all that alpha radiation. We're only picking up really the beta radiation. And so you can see it's radioactive, but not nearly as radioactive as that first sample. Let's go back to that first sample. That was impressive. Just immediate rise in CPM. Not something you would want to carry around in your pocket on a daily basis, that's for certain. But again, you pull it away from the sample and the radiation levels drop considerably. So let's talk about the enclosures. These enclosures are plastic, and so it blocks a lot of the radiation just simply because we're not dealing with serious radiation like gamma rays that can penetrate through things very easily. Thank you for watching. You're looking at the living periodic table, and we'll just go through the elements. And I'll show you samples and give you stories for why I chose those samples in each box.